Hi, this is Algebra 1, Lesson 1-2, Solving Linear Equations. In this lesson, we'll be able to create and solve linear equations with one variable. Let's start with model and discuss question. Joshua is going kayaking with a group during one of his vacation days. In his vacation planning, he budgeted $50 for a kayak rental. If you look at the picture here, we can see the rental rates here. Single kayak is $15 per hour. Single sea kayak is $18 per hour. Double kayak is $25 per hour. Part A. How can Joshua determine the number of hours he can rent a kayak for himself? Describe two different options. So if he has $50, how can he determine the number of hours he can rent a kayak for himself? He could do single kayak for 2 hours to get $30, and in that case he only has $20 left. So if he wants to do a single sea kayak for an hour, he could do that. Or if he just wants to do 3 hours of single kayak, that's also possible, right? So let's write that down. Part A. Joshua could make a table of the cost cost per kayak for a different number of hours, and go with the option that closest fits his budget. He could also create an equation with the rental rate R times the number of hours H set equal to 50. So mentally, you can think of adding them one by one and just subtracting them from the budget. But how is the problem? So there could be multiple different ways to represent his thoughts. He could make a table, or he could make equations. Part B. Joshua found out that there is a $20 non-refundable equipment fee in addition to the hourly rates. How does this requirement change the mathematics of the situation? So he not only has to pay for the kayaks per hour, but he has to pay a $25 equipment fee. So all the safety equipment that he needs to get, the rowing, he needs to pay $25, and it's non-refundable, so he doesn't get it back. How does this change? That means if he budgeted for $50, now he can only use $50 minus $25 for renting the kayaks. So if he has an equation that says H hours times rate R equals 50. So in part A, you can say HR is equal to 50. But how does that equation change? So the hour times the rate has to be subtracted by 25 to get 50. Or you need to add 25 or you can say 50 minus 25 is equal to HR. Okay, So part C, how do the processes you use for parts A and B differ? How are they different? How are they the same? So in part A, what did you do? You didn't think about the non-refundable equipment fee. So you just had to simply think about how many hours we could play for each kayak. Right? Part B, you had to include the equipment fee, so it changes the budgeting. But both require solving an equation. The equation in part A can be solved using only division, while the equation in part B requires subtraction and division to solve. Okay, so think about this essential question throughout the lesson. How do you create equations and use them to solve problems? Let's look at example 1. Solve linear equations. What is the value of x in the equation 2 times x plus 4 divided by 3 minus 8 equals 32? You want to solve for x. Method 1. You can multiply each side by 3, and don't forget to multiply negative 8 by 3 as well. So if you multiply each side, the whole thing is multiplied. So you get rid of the 3 in the denominator for the first term. And negative 8 times 3 is negative 24. 32 times 3 is 96. And then you use the distributive property to get rid of the parentheses. 2 times x plus 2 times 4 is 8. And then you subtract the like terms, and you divide by 2 to get x is equal to 56. Another method, method 2, is instead of multiplying 3 on both sides, you're going to add 8 on both sides to get rid of the 8 first. So you get 32 plus 8, so it's 40. And then you multiply 3 on both sides. So you get 2 times x plus 4 equals 120. And then you use the distributive property and use the subtraction to get x is equal to 56. Either way, you should get the same answer. What are the differences? It's just a matter of the order. In method 1, you just need to be careful that you multiply 3 for the second term as well, negative 8. If you don't do that, then you will get a different answer, and that is incorrect. In order to minimize your mistakes, method 2 could be preferred, so that you only have to worry about multiplying 3 in the first term. So this is often a good strategy and can lead to simpler solution methods. So now it's your turn. Let's look at Triad. Number 1, solve the equation 4 plus 3x minus 1 divided by 2 equals 9. Explain the reasons why you chose your solution method. So for each step, you could justify your answer, and then you can choose your, you can explain why you chose method 1 or 2 from example 1. So if you can do this by yourself, come back when you're ready for answers. Okay, what was your first step? If you chose method 1, you can multiply 2 on all the terms. If you chose method 2, which I'm gonna go by, you're gonna subtract 4 from both sides first, so that you can isolate the fraction. So your next step, if you're choosing method 2, would be 9 minus 4, which is 5. So 3x minus 1 divided by 2 is equal to 5. And then the next step, you will multiply 2 on both sides. Getting rid of the denominator, you simply just get 3x minus 1 is equal to 5 times 2, 10. And then you would solve for the equation. You add 1 on both sides to get 3x is equal to 11. And finally, your x is equal to 11 over 3. Check your answers. Did you get the same answer? If not, go back and look at your steps to see where you got a mistake. If you chose method 1, please make sure that you multiply 2 on 4 as well when you get rid of the denominator here and multiply 2 with the 9. Alright, moving on to example 2. Solve consecutive integer problems. The sum of 3 consecutive integers is 132. What are the 3 integers? You don't know what the integers are, but you need to figure out the consecutive integers. What does consecutive mean? It means right after another. So 1, 2, 3 would be consecutive integers because they're in the order of consecutive integer. Okay? 3, 4, 5 is also consecutive. So it needs to be right after another in the integer order from least to greatest. So you want to figure out the 3 integers. Because that you know that they're consecutive, you can write those numbers as in terms of x. But x would be your first integer. Your next integer, it should be x plus 1 because they're consecutive. And then the next one should be x plus 2 because they're all consecutive. So x plus 1 plus x plus 2 will represent the sum of 3 consecutive integers. And you can let that equal to 132. So then you just have to combine the like terms. X plus x would be 3x, and 1 plus 2 would be 3. And subtract 3 on both sides, divide 3 on both sides, and then get the answer. X is 43, which means your first integer would be 43. So the first of the 3 consecutive numbers is 43. That is not your answer. You need to figure out the 3 consecutive numbers. The 3 consecutive numbers, whose sum is 132, are 43, 44, and 45. This is a good strategy for figuring out multiple consecutive integers. So now it's your turn. Look at try number 2. The sum of 3 consecutive odd integers is 57. What are the 3 integers? Pause the video, see if you can figure it out by yourself, and come back for answers. Okay, using the same method, x plus x plus 1 plus x plus 2 would equal to 57. And solving that equation, you should get 17. Wait. Be careful, they're odd integers. So instead of using x and x plus 1 and x plus 2, what should you do? If x is an odd number, x plus 1 is an even number. So you cannot use x plus 1 as a consecutive odd integer. The next consecutive odd integer after x would be x plus 2. And if your second term is x plus 2, then your third term should be x plus 4. Because x plus 3, in the same way, should be an even number if x is an odd number. Odd number plus an even number should be an odd number. So solving for the equation x plus 2 plus x plus 4 is equal to 57 should give you 3x plus 6 equals 57, which gives you 3x is equal to 51, which gives you x is equal to 17. So your first term is 17. Your next odd integer should be 19. Your next odd integer should be 21. So look out for odd integers and even integers. Example 3. Use linear equations to solve mixture problems. A lab technician needs 25 liters of a solution that is 15% acid for a certain experiment, but she has only a solution that is 10% acid in a solution and a solution that is 30% acid. How many liters of the 10% and the 30% solutions should she mix to get what she needs? This is a tricky question that a lot of people are confused about. But think about the percentage of the solution. The acid determines the percent of the solution. That means if you have a fluid of 100 liters, then 15% of 100 would be 15 liters. So 15% of acid has 15 liters of acid in 100 liters of a solution, right? So thinking of that, if we have 25 liters instead of 100 liters, 15% of acid has how many liters of acid? How do you know? You need to figure out what 15% of 25 is in order to figure that out. So in order to figure that out, 25 times 0.15, which is a decimal form of 15%, gives you the liter for the acid. In the same way, you can figure out how many liters of acid you have for a 10% solution and 30% solution. So 3.75 should equal to 0.1x plus 7.5 minus 0.3. Why do we have 7.5 minus 0.3? So look at your original equation. You're going to use all the information that you have. 25 liters of 15% solution is what you need. But she only has a solution that is 10% acid and a solution that is 30% acid. You don't know how much liters she should mix them so that she gets exactly 15% acid solution for 25 liters. So she needs to mix the liters of these solution, so the sum of them should be 25 liters. But you need to think about the acidity of the solution. So we're going to just look at how many liters of acid that she needs. So x is the amount of liters of acid in one solution. Oh wait, no, x is the amount of liter that she's gonna mix for this solution. And the amount that she mixes times 10% would be the acid that she has. And the amount that she mixes is subtracted from 25 for the 30% solution because you need to make a total of 25 liters. So if she uses X amount of liters for a 10% solution, then you need to subtract 25 minus X to get the other liter of solution. So that's why we have 25 minus X times the acidity, 30% solution. So if you multiply 0.3 times 25 minus X, which represents how many liters of solution that she mixes for the 30% one, you will get how many liters of acid she has. So if we add the acids, the liters of acids that she needs, then to be equal to 3.75, then we'll be able to figure out the liters of acid that she needs. So solving for this equation, step by step, you'll get that x is 18.75, which means she'll have to mix 18.75 liters of 10% solution, and 25 minus x would be 6.25 liters of the 30% solution. So together, 18.75 and 6.25 should add up to 25 liters. And acidity also lines up to the exact amount of acid she needs for 25 liters of solution. Okay, so now it's your turn. Try number 3. If the lab technician needs 30 liters of a 25% acid solution, how many liters of the 10% and the 30% acid solutions should she mix to get what she needs? So it's the same type of problem. Instead of 25 liters, she needs 30 liters of a 25 acid solution. So using the same equation, you can figure this out by yourself. So if you can do it by yourself, come back when you're ready for answers. Are you ready? Needs 30 liters of a 25 acid solution, then we can use the same equation from the example above and say 0.25 times 30, and that's equal to 10% of the amount of 10% solution plus 30% times the amount of 30% solution, which is represented by 30 minus x. So make sure that you put 30 here and 30 here because you need 30 liters of the whole solution. And then after setting up your equation correctly, you're going to solve for the equation. 0.25 times 30 is 7.5. And that should equal to 0.1x plus, using the distributive property, 30% of 30 should be 9 liters, and minus 30% of x. And subtracting 9 on both sides, you should get negative 1.5. That's equal to negative 0.2x. And so, solving for x, you get x is equal to 1.5 divided by 0.2, which is equal to 15 divided by 2, which is equal to 7.5. So that means x, the amount of 10% acid solution we need to mix is 7.5 liters, and the amount of 30% acid solution she needs to mix is 30 minus 7.5, which is 22.5 liters. So write that down, 7.5 liters of 10% solution and 22.5 liters of 30% solution is the answer. Okay, look at the next problem. Example 4. Use linear equations to solve problems. 4 friends use an online coupon to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of one ticket without the discount? So if you look at this picture, it says that your online order is complete. Your order details are shown below for your reference. Order number 328, section B, row 10, seats 13 to 16. And it says that the quantity of the ticket we bought is 4. We don't know the price, but the discount we got for each one is $15. So times that by 4 should give you $60 of a discount total. And so whatever the price was, the order total was $312. So first step, you're going to write an equation to represent the problem situation. you can let P represent the original ticket price. So 4 times P is equal to 4 times P minus the discount is equal to 312. So you can write that down as 4P minus 4 times 15, or you can put a parenthesis and say 4 times P minus 15 is equal to 312, but they're the same thing. Now solving for P, you will get 93, which means the ticket price without the discount was $93. So make sure you know how to set up an equation. That is the most crucial part. You should already know how to solve the equations after you set up them. So now it's your turn. Let's look at try number 4. The same 4 friends buy tickets for 2 shows on consecutive nights. They use a coupon for $5 off each ticket. They pay a total of $416 for 8 tickets. Write and solve an equation to find the original price of the tickets. See if you can solve by yourself. Come back when you're ready for answers. Alright, are you ready? First off, how would you set up an equation? The important information here is that they bought 8 tickets, and the total was $416. The discount was $5 for each. So you can write the table again by substituting your tickets and the quantity of the tickets and discounts. So you bought 8 tickets and you don't know the price, so that's P. And then the discount is $5 off for each. So 8 times 5 would be the total discount. Writing the equation, you should have the equation of 8 times t minus 5 should equal to 416. Or 8t minus 8 times 5 is equal to 416. Okay, so solving for t, you should get t is equal to $57. So the original ticket price was $57. Alright, the last example on the next page, example 5. Solve work and time problems. Latanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair. Then she will ride her bike home. Can she be home in 1 hour? If you look at the map, her home is here and the bike shop is here. So from her home to bike shop, if she walks at 3 miles per hour and bikes at 10 miles per hour, can she be home in 1 hour? So write an equation to represent the situation. The time walking would be 1.5 miles divided by 3 miles per hour. Why? Because we know 1.5 mile is the distance from her house to the bike shop. So 1.5 divided by 3 would give her how many hours she walked. And time at the shop she spent was half an hour. And time biking, we could also do the same thing with the distance. 1.5 miles divided by 10 miles per hour will give her how many hours she biked. So the equation simplified would be 1.5 over 3 plus 1/2 plus 1.5 divided by 10 equals t. And solving for t, you can multiply both sides by 30 so that you can get rid of all the denominators. 30 is the LCM, the least common denominator for 3, 2, and 10. And so multiplying by 30, 30 divided by 3 is 10. 10 times 1.5 is 15. 30 divided by 2 is 15, times 1 is 15. 30 divided by 10 is 3, times 1.5 is 4.5. And that's equal to 30t. And if you divide both sides by 30, you isolate the t. And that's equal to 1.15. It'll take her 1.15 hours, or 1 hour and 9 minutes, to get home after leaving to get her bike repaired. So she will need more than an hour, would be the answer. Okay, look at the try question. Now it's your turn. LaTanya leaves her house at 12:30 p.m. and bikes at 12 miles per hour to Marta's house. She stays at Marta's house for 90 minutes. Both girls walk back to LaTanya's house along the same route at 2.5 miles per hour. They arrive at LaTanya's house at 3:30 p.m. How far is Marta's house from LaTanya's house? Now we know the exact time it took, but we don't know how far Marta's house was. So that is going to be our variable. See if you can solve this by yourself and come back when you're ready for answers. Okay, are you ready? So what relationship can you use to write an equation to represent this situation? The equation that we used in the example 5 was that distance equals rate times time. So using this equation, you can figure out the distance and using the information given for rates and time. So if she leaves her house at 12:30 and then stays at Marta's house for 90 minutes and then come back at 3:30, from 12:30 to 3:30, what was the total time they took? The total time would be 3 hours, right? But 90 minutes is an hour and a half. So it means that she biked and to her house and walked back with a total of an hour and 30 minutes. So we don't know the distance, but we know the rate and the time. What are the important information that you need? LaTanya started at 12:30 and they arrived at 3:30. So total time should be how many hours? From 12:30 to 3:30, total time is, let me type that. Total time is 3 hours. And so we know this information now, right? What about time walking? Time at the shop. So we know all the other information. So now let's fill in using the equation. Let's set up an equation like that. So time biking to her house would be 12. We don't know the distance, so let's put a d as a distance divided by 12 miles per hour. Okay, that is a fraction. And then we're going to add the time they spent there, which is 90 minutes, but we need to write this in terms of hours so that all the numbers represent the same thing. So 90 minutes is 1.5 hours. And then we're going to add the time going back to her house. So that's going to be distance, which we don't know, divided by 2.5 miles per hour, and that is the time going back. And this all needs to equal to the total time, which now we know is 3 hours. Okay, so because we know all the other information, we can solve for distance d. And so solving for this equation, the next step, you can simplify this equation by saying d divided by 12 plus 1.5 plus d divided by 2.5 is equal to 3. And so d, by multiplying 12 on all the terms, you can get d plus 18 plus 4.8, d is equal to 36. And that gives you 5.8, d is equal to 18. So d is equal to 18 divided by 5.8, or 90 divided by 29, which is approximately about 3.103448 ... So what is the answer? Marta's house is about 3.1 miles from Latanya's would be the correct answer. Okay, so use the same equation. The time walking is distance divided by speed. The important equation that you need to know, which will always be given. So if you don't know, you can ask Ms. Kang, what is the equation for distance and time and rate? Your distance is always equal to rate times time, RT. So using that, the time is equal to distance divided by R. So that is how we came up with the time walking plus time at the shop and the time biking and the total time. Okay? When we're setting up an equation, just make sure all the terms are representing the same thing and they're using the same units. Okay, let's summarize our lesson, creating and solving linear equations. We created a lot of equations and solved them in this lesson. You can use the following information. You can use the important information to set up the equations. This is just an example for Kelsey visiting to the flower shop. Alright, that was lesson 2, solving linear equations. If you have any other questions, please feel free to ask Ms. Kang in class. Lesson 3 would be our next lesson, solving equations with a variable on both sides. So